Here we are going to start the concept of data structures using C++. First of all, let us understand what is meant by a data structure. Structuring of the data in the format of coding or programming, we can say. So let us understand first of all the definition of what is a data structure. Data structure is a fundamental concept of any programming language essential for algorithmic design. Okay, it is basically used for algorithmic design purpose and solving the programming concepts. It is also used for the efficient organization and modification of the data. Okay, for retrieval of the organized data, for searching the data, for retrieving the data, for modification and all, we will be using this data. Data structure is nothing but how the data and the relationship among the data is represented. Means suppose you're storing the data in the form of a table, okay, and you want to display it in the form of a hierarchical format. So that is the relationship between data and the structure of how it is being stored and how it is being used for modification and all. So basically we will be applying the algorithms over here for modifying and applications of the data structure. Now let us understand what are the various types of data structures. The first one is a linear data structure, that is mean by linear in the sense in the sequential format how we are storing the data. Sequential order, like in the line format. If at all you are storing the data in the line format, it can be the example of an array, okay, where we store the elements in the sequential order of memory. So that is one of the type of the data structure, and the other one is the non-linear data structure. In the linear, you also have certain examples like linked list, stacks, and queues as well, where it uses the strategy of sequential storage of data into the memory. Now coming to the non-linear data structure, the name itself is defining that it is not in the form of a line. Okay, so here we are giving the structure of the data in the form of either the tree or the graphs concept, okay, which is non-linear, and where the traversals takes place for moving from one node to the other in the trees and in the graphs as well. So these are the various types of data structure. If you see this is the flow chart of the data structure, various types. Data types is subdivided into primitive data structure and non-primitive data structure. In the primitive, you have the types of data like the integer data, floating point, in this nothing but the decimal values that we are storing, individual characters or Boolean data that is going to represent the data in two forms, either it is the true case or the false case. Similarly, in the non-primitive data structure, we are having linear data structure and non-linear data structure. In the linear, again, you see the arrays, linked list, stacks, and queues. And in the non-linear, you see there it has a trees and the graphs concept. Okay, so this is the flow chart of the data structure. Now, let us understand few of the applications of data structures, where it is being applied and how it is being useful. Basically, the main and the foremost usage of the data structure is for the efficient programming or algorithmic design, and how efficient the data is structured, that we will be keeping as a criteria. Identifiers, lookups in the compilers implementations are built using the hash tables. That is, you can consider the example of the hash tables where we see the index. I'll give you the other example of your textbook, where we have the index in the front page of the textbook, where we will be navigating to the pages and the concepts of individual page number with respect to the topic and the page numbers. So that's how the linkage is given to your hash tables as well here. The other application would be your B trees. That is another advantage of the data structure for suitable database implementation, we can say. And some of the important areas where we will be applying the data structures are artificial intelligence, AI concept, compiler design, ML, machine learning, database design and management, blockchain, numerical and statistical analysis, operating system development, okay, and image and speech processing, cryptography. So these are the various areas where we are applying data structures on a wider basis. Now, let us understand few of the concepts where the benefit of learning the data structure is. It is basically used in solving the problems like how fast the data can be retrieved, or how fast the problem can be solved. Okay, the timing constraint we can consider over here, and how much less resources will be used for storing the data, that is the space complexity. Basically, the whole and soul data structure will be designed upon the analysis of the data with respect to time complexity and the space complexity, and that is going to help us identify the benefits of learning the data structure. Okay, so these are the two basic constraints of time and the space complexity, which will be solved efficiently by using various what I can say algorithms or the techniques that we are implementing over here. In order to do this, it is very much essential for the given problem to be represented in a proper structured format upon which the efficient algorithms can be applied. And after that, we can also say that selection of the proper data structure becomes most important step, okay, for before applying the algorithm and for solving its problem. Now, coming to understanding the concept of what is an algorithm. So algorithm is nothing but it's a method or a process of step-by-step solving a given problem. Like representation of the algorithm could be in the form of solving a given problem in a step-by-step manner. For example, if you're traveling from your home to the college, you follow certain steps. You first of all come out of your home, take the respective traveling option, means of traveling, okay? Then you will take so many directions for moving on to the destination, right? And finally, you will reach your destination, that is your college. So that is a step-by-step process that is helping us to solve the problem. Similar is the algorithm. It is a step-by-step process for solving a problem. It is a method for finding the right answer to a given problem or a different problem by breaking the problem into simple cases or simple steps. Okay. So what must be the properties of the algorithm? First one is finiteness. You must be having the finite number of steps in your hand before executing a given problem. The solution should be in the finite number of steps. Definiteness. Each and every step of the algorithm must be clear and precise in nature. It should be understandable by the end user. That is the second advantage of the definiteness of the algorithm. Now coming to the effectiveness, the step whatever you are implementing or applying, it should be effective in nature. It cannot be like it is not effective. If it is not effective in any of the circumstances and all, and then it could not be considered, right? That step could not be considered. So it will give you exactly how much amount of time will be invested upon it and how much amount of space will be applied upon it. Generality. Algorithm should be complete in itself so that it can be used to solve all the problems of given type, okay, for any given input data. So generality must be there in it. That means it will be completing on in the given precise area only. Number of inputs and output must be very, very clear, and the values must be very, very clear. And each algorithm must take 0, 1 or more inputs and also give the respective outputs as desired. Based upon the input, whatever the expected outputs are required, that must be given by the algorithm. So these are the properties of an algorithm. Now, let us understand what is a pseudocode. Pseudocode is also the implementation of the code. Okay. Before writing the code in the actual programming language, we design the pseudocode of it. It is another version of algorithm, I can say. So what is a pseudocode? An algorithm can be written in English like sentences, okay, or in any standard representation, okay. Then the algorithm written in the English language is called as the pseudocode. Means whatever the steps you're writing in the English language, like you have to get out of your home, take the respective traveling means of travel, like a bus or a metro or an auto, whatever it is. So you are explaining the steps in the English language, right? And that is called as your pseudocode. For example, here to find the average of three given numbers, the algorithm is shown in the given number of steps here. Okay. So first of all, you will read the three numbers A, B, C, and D is for storing the data, that is the resultant output. Then compute the sum of the three, divide the sum by 3 for performing the average of it, and store the resultant variable in the variable D, and that is the end of the process, right? So we are giving respective number of steps here for solving the problem for finding the average of three given numbers. Yes, so we considered here steps are finite, definiteness is there in it, okay, and what I can say, number of given inputs and outputs are desired as expected, and this is going to solve my problem, right? So that is the pseudocode. Now, a pseudocode is a method of describing computer algorithm using a combination of natural language and programming language. Yes, like it will be using the combination of the English language and as well as few of the programming concepts into it, like for loop, if at all we are using, will make use of the keywords with the respective syntaxes and all. So that is going to depict into your pseudocode. Pseudocode notations, it uses the various notations like the header purpose, pre-post conditions, return statements, variables, statements, and the sub-algorithms. So these are the various notations of your pseudocode. Let us see each one of them. Algorithm header, it includes the name of the algorithm or parameters or the list of pre and post conditions. Whatever you are specifying as a header or name of the program or subprogram, everything will be given to you in the algorithm header. Next is purpose. It is a brief description about what the algorithm does. Purpose. So you are giving the description or the explanation about what is the algorithm about. Next, condition and return statements. The precondition states the pre-requirements of the parameters. Here, whatever the conditions you are considering, it will be giving you the pre-requirements and the resultant outcome of it. And the post conditions will be identifying or the actions taken by for solving the given problem in the number of steps, right? Based upon the return statement, okay, or the return condition. Statement number, the statements in an algorithm are the numbered sequentially. Yeah. So in the order of the sequential number only our execution takes place. So statement numbers is also one of the important point. Variables, number of variables allowed in the algorithm or used in the program, that should be notified to the user. Statement constructs. So how the statement is being constructed, either it is a sequential statement or it is a decision statement or it is a repetitive statement. Okay, like the flow of the statement, how it is it going to be in a sequential order, conditional basis, if the condition is true, how it is going to execute further, if the condition is false, how it is going to execute further. Repetitiveness, like looping, 10 times I have to print the following line, so it is going to be under the repetitive statement. So these are the statement constructs. And sub algorithm is also called as sub program function, means a small program which is going to be called again and again as per the requirement of the user, okay, or as per the requirement of the program for giving the solution for it, okay. So these are the various representations and the notations of the pseudocode. Moving on to relationship between the data structure and the algorithm, how they are related to each other. Let me just clarify you, data is nothing but the factual information. Example, such as that is dependent upon the measurements and the statistical data. For example, today's forecast, okay, weather forecasting we can say, or the counting of the number of benches in the classroom, number of books arranged in the row, okay, number of papers collected. So all that is a factual data which is available for you for discussion, for calculation, and for reasoning purpose. Okay, that is the raw data which is available in the hands. That is your data. Now coming to the data structure, are the objects generated to store data, and algorithms are a set of instructions to perform the specific task upon the data structure. Means whatever the data is available, you are structuring it either it in the form of a sequential line order, or a tabular form, or a hierarchical basis, or in the form of a stack queue, or in the form of a tree or a graph. So all these are the structuring of the data in various forms with the help of the objects. Okay, either you're going to store it in the stack, means stack is an object where we are storing the data into stack format, right? If not, tree format where we are having the root element and the subnodes and so on. So that we will be applying for the storage of the elements into the data structure, and that is how it is related to the data. When the data is available, then only you can form the structure of it. If the data is not available, you cannot structure it. Okay, so that's how the relation between the data and the algorithm is, the data and the data structure is. Now coming to the algorithm, it's going to give us certain number of steps for solving the problem of the user. Okay, and it will end up the task to be solved by respective number of steps that should be applied upon the data structure. Okay, so this is how they are related to each other. Now, what is an algorithm? I can say that it is the lifeblood of our work, and it is the nerve that gives the life to any of the computer program, we can say. And how this person has defined data structure and algorithm is, we can define the data structure and algorithm in one statement as the structural organization is known as the data structure, and the ways in which the operations are carried out as is known as the algorithm. Structural representation of the data is your data structure, and the various operations or the ways how we are going to apply the operations upon this data structure is called as your algorithm. And this is how it is being defined in a single statement by one of the author, we can say Sally and Kent. Okay. So this is one of the example for addition of two numbers, and the values are entered by the user. These many number of steps. Initially, we start the process. We declare the number of variables that we require, number 1, number 2, and sum we are storing in the sum variable. So these are my 3 variables there. Now, reading the values for num1 and num2, user will be entering the values at the runtime. So we are reading it from the user, performing the sum of them into the fourth step by writing the formula sum is equal to num1 plus num2, finally displaying the sum, and that is the end of the process. These are the respective steps in a algorithm. Now, coming to the implementation of data structures. Data structures can be widely viewed in terms of specification and implementation. Specified data in the form of, this is the first phase where we specify the data, how it should be designed and what are the necessary steps, how it will be implemented and so on. Okay, so designing of the data is specification, in which area, under which area it will be applicable. The second phase of the implementation of the data structure is called as implementation stage. In this stage, we will define all the functions with respect to the descriptions and how it should be manipulated and so on. So this is the stage where we will be applying the respective algorithms, problem solving techniques, sorting techniques, searching techniques, whatever it is, we will be applying it in this second phase of data structure for giving the solution, right solution to the right problem. Okay. Now, let us analyze the algorithm. How the analysis of the algorithm will be taken place. It is very, very important for analyzing the algorithm of a problem after developing. Once the algorithm has been developed, we have to analyze it to get to know how efficiently that algorithm is applicable and how far it can be used by the end user, right? So one way of analysis is to check the logical correctness and implementation through testing. Yes, so this is one of the ways of analyzing the data. One is complexity of the algorithm. We will be getting to know how complex the algorithm is by using its functionality, which measures the time and space complexity used by an algorithm in terms of input size, that is termed as n. Okay, so complexity of the algorithm will be known. Second is space complexity. That means what is the amount of memory that will be occupied for storing this data into the memory. And for running, when I implement this data structure or apply this algorithm, what is the amount of space that is required for running and executing it onto the system? That will be important to analyze. So in the multi-user computer system, we may need to specify the amount of memory to be allocated. Yes. So in this era, as we know, the systems that we are using is not enough for storing the data. We are purchasing the clouds and all for storing our data, right? On that basis as well, for allocation of the data and the memory space, it is very, very important to know how much it is required. What is the space complexity? What is the time complexity? In what amount of time it is going to give me the respective output. So for that, we will be finding the time complexity with respect to compile time plus runtime. How much amount of efficient time it is going to highlight the errors, that is with respect to compile time, and runtime, it is how efficiently it is going to execute the code and give me the output. Okay, so that's how we will be calculating the time complexity and the space complexity of an algorithm by using the data structure.